In this video, we're going to look at the names of other 3D objects, as well as start discussing the volume and how to find the volume of specific shapes. So, you may recognize a lot of these different shapes. We recently talked about a prism, and remember the definition of the prism is a solid with two parallel and congruent bases. And it says here, not all 3D shapes have these traits. So, again, you may recognize them. They're everyday objects, such as an ice cream cone, a basketball, and these everyday items are specific geometric shapes that we're going to discuss in this unit. So, this first one, it is an ice cream cone because it is the geometric shape that it also entails, and this also, most of these shapes have to do with the base of our cone, whether or not it is facing upwards, like you would have a normal ice cream cone, or kind of the opposite direction. That base is going to be a circle. Okay. And then it kind of looks like a triangle, right? It is rounded, so we'll discuss a little bit more about a cone later. The basketball here is going to be a sphere. Okay, a sphere is a three-dimensional circle. It does have a radius, just like a regular circle would have, but now my radius can go anywhere. It can come out at me. It can go back into the screen. So we know it's three-dimensional. Technically, a sphere does not have a base because it's rounded all around. Next, we have a can of soup, which I'm sure you've seen many, many times. This is what we call a cylinder. Okay, a cylinder is very similar to a cone, but it's also similar to a prism because it does have two circular bases. So here is the base up on the top, that's a circle, and then it would have a similar base on the bottom. So it does in fact have two bases, one on the top and one on the bottom, that are parallel to each other, just like our definition of a prism. But we don't consider it a prism because those lateral sides are round. A prism has flat lateral faces. This next one, this tissue box, this is our prism. Specifically, this one would be a rectangular prism because our base is a rectangle. Again, there would be one on the top, and parallel to it, there would be one on the bottom. That one we know, just to remind you. And the last one here is a pyramid. Okay, and just like a prism, we could have a square base, we could have a rectangular base, we could have a triangular base. A pyramid could be the same thing. Our base can be a rectangle, our base can be a square, or our base can be a triangle. It just depends on the shape of the base. So, now that we know those names, we're going to look at them in terms of our 3D objects, and we're going to start talking about volume. So let's flip to that next page. So, the definition of volume, volume and surface area typically go together. However, they are completely measuring different things. And as we saw in our last note page, the surface area is still measured in meters squared, right? Units squared. It's still just finding the flat area that if you unfolded the shape or if you wrapped the present, how much flat wrapping paper would it take? Well, now our volume is talking about filling. So volume is the amount of space inside of an object. So like I said, it's filling it up. How much water would it take to fill my prism? And we always measure volume in units cubed. Okay, so this is the first time we're starting to talk about units cubed. And each of these shapes that we talked about on that last page has a specific volume formula. And the cool thing is that on the SAT, you're actually going to be given a formula sheet and it looks exactly like this. There's a couple other things that are on there, but it's important for you to be able to look at this formula sheet, and if there's a question that involves finding the volume, got to know how to use these specific formulas. That SAT is an important test. So in these boxes here, I would like you to take a second, fill them in with the shapes that we wrote down in our last note page, because we also have to be able to identify which shape is which. So go ahead and pause the video and fill in these boxes with the specific name that we discussed on that last page. So make sure you have the correct names. Again, if the problem says to find the volume of the prism, make sure you are using this prism formula. If it says to find the volume of a sphere, we're going to use this one here, and the volume of the cylinder. Those are the three that we're going to focus on today. And again, each of these individual pieces are labeled, right? So length times width times height, that is the volume of a prism. A cylinder is pi r squared, which is the area of the circle, times that height. And then our sphere is 4/3 pi r cubed. Make sure you notice that cubed. If we want to write it as one big fraction, 4 pi r cubed all over 3, feel free to do that as well. Sometimes it makes it a little bit easier. It's kind of just personal preference. So let's go ahead and find the volume of the rectangular prisms with the dimensions 6 by 8 by 12. So it really does not matter which side is the base. It doesn't matter which side you put is the 6, is the 12, because the volume formula for our prism is just going to be the length times the width times the height. So again, it doesn't matter. You could rewrite those letters in any order, just based on our picture here. Again, I'm going to label them. Doesn't matter which number you put where. One is the length, one is the width, one is the height. If you wanted to, you could make it maybe a little bit more accurate in your picture. But there you go. In your calculator, you just type those three numbers in, multiply them all together, and you get 576. So our total volume is 576, and remember, meters cubed. That's because we're multiplying three numbers together. Three numbers, m cubed. Now let's find the volume of the cylinder. Again, using this formula that we have up above, I'm going to rewrite it so we remember. Pi r squared h. Again, all those numbers are being multiplied together. Our radius is 6, and our height is h. So I'm going to find the exact area by taking my radius and squaring it and multiplying it by my height, 8. So 6 times 6 is 36. And then again, I'm going to multiply in my calculator 36 times 8. And don't forget about that pi at the end. So our total volume is 288 pi cubic feet, feet cubed. Again, three numbers being multiplied together. The third number there is pi. Pi is a number, 3.14. And last but not least, the volume of the sphere. Again, I'm going to write down that volume formula. It's 4 pi r cubed divided by 3. So all we need for the volume of a sphere is to know the radius, which we are told is 12 centimeters. So we have 4 times pi times 12 to the third power, all divided by 3. So we're going to take this step by step. In your calculator, you're going to do 12 cubed first, and this is going to be a pretty big number. So I still have the 4, I still have the pi, I still have the divided by 3. 12 cubed is 1728. Next, I'm going to multiply the 4 and the 728. Again, it's going to be a pretty big number here. We get 6912. Don't forget to bring the pi over. Don't forget to bring the divided by 3 over. And last, I'm going to divide the two numbers. 6912 divided by 3. We get 2304. And don't forget about that pi for our volume of the sphere. 2304 pi centimeters cubed. So again, if you have those formulas, we are able to find the important information, whether it's the radius, the height, the length, the width, all those values, plug them into the formula, use our calculator to help us do some multiplication, and we have the volume of a solid.